Hi everyone. In today's video, I'll be explaining a way to approximate the value in 3 decimals of the root of 145 minus the root of 143. So it's a kind of way to approximate the roots without using a calculator. So the method one is going to be the perfect square formula. So we have a plus b squared is equal to a squared plus b squared plus 2ab. Now, we could rewrite this root as this formula. So how do we do that? Well, first we have to assign an a. So the a here is going to be how to find it is we're gonna have to find the biggest square number that's smaller than, for example, here 145. Now that's going to be 144. 144 can also be written as 12 squared. So now we already found our a. The a is going to be 12. Now the remaining number, so for example here 1, is going to be the 2ab. So we're not gonna find the b squared now. This is gonna be for later. So now 12 squared plus 1 is gonna be a squared plus 2ab. Now we already know a is 12 and 2a is gonna be 24. So b has to be 1 over 24 so that 2ab is equal to 1. So now we have root of 12 squared plus 2ab, so 2 times 12 times 1 over 24. Now we could find b squared, and we already got b, which is 1 over 24. B squared is going to be 1 over 24 squared. So now what we're left with is 12 squared plus 2 times 12, 2 times 12 times 1 over 24 plus 1 over 24 squared, which is b squared. And then because we did plus 1 over 24 squared, we got to do minus 1 over 24 squared. And as you noticed, now we finished rewriting the equation as like the formula here. So 12 is going to be a, and 1 over 24 is going to be b. So now a squared plus 2ab plus b squared, and then minus b squared is going to be equal to, this is a plus b squared minus b squared. And because b squared here is a very small number, it's approximately 1 over 500, we can omit that. It's not gonna be important in our final answer because we're making an approximation. So now what we're left with is the root of 145 is around the root of 12 plus 1 over 24 squared, which is, now that the root and the square can cancel each other out, we're going to be left with 12 plus 1 over 24. So that's going to be the final answer, approximated, of a root of 145. So now we're going to do the first method again, but using a different formula, which is kind of similar, but now we're using a minus here. So it's a minus b squared is equal to a squared plus b squared minus 2ab. So now here we're going to use it on the root of 143. The root of 143 can be written as the root of 144 minus 1. And we chose 144 because it's the smallest square number bigger than 143. And now minus 1. And 144, as I said before, can also be written as 12 squared. And now we got to find minus 2ab. So now it's minus 1, so 1 has to be 2ab. And as I said before, 2ab has to be 1, which means b has to be 1 over 24. Now we found b, so we can rewrite the whole entire thing as the formula here. So now we have 12 squared minus 2 times 12 times 1 over 24 plus b squared. So here we have plus b squared, which is going to be 1 over 24 squared. Then because we did plus b squared, we got to do minus b squared. Now this is going to be equal to root of 12 minus 1 over 24 squared minus 1 over 24 squared. And the 1 over 24 squared is a very small number. It's around 1 over 500. It's smaller than 1 over 500. So we can omit that decimal. So now we're left with the root of 12 minus 1 over 24 squared. Now the root and the squared cancel each other out. So we're left with 12 minus 1 over 24. So that's going to be our approximated answer of the root of 143. So now we could use our approximations to find the solution. So here, for example, 12 plus 1 over 24 minus 12 minus 124, 1 over 24, gives us 1 over 24 plus 1 over 24, which is 1 over 12, which is around 0.083. So the second method is going to be the square root approximation formula. So we have the root of n plus or minus delta is equal to plus or minus delta over 2 over square root of n. So keep in mind this is an approximation. So now here, for example, and plus or minus means that it works in both ways. So for example, here root of 145 is equal to root of 144 plus 1. So now we're using the plus. So now here we're going to use the plus is equal to root of 144 plus 1 over 2 times root of 144, which is 12 plus 1 over 24. Now, if we were to use the minus, it'd be the same thing, but this time we'd be using the minus for both, uh, yeah, both sides. Now, the answer is going to be 12 minus 1 over 24, and now we can calculate the difference, and it's going to give us the same number, which is 0.083. So the third method is going to be the linear approximation formula. So here's the formula, and in this formula, x is going to be equal to um, the number whose root we're trying to find. So for example, here x is going to be 145 and here it's going to be 143. A is going to be a square number close to x, so that function of a and the derived function of a are going to be easy to find. And also we also know that the function of x, if the function of x is equal to the square root of x, then the derived function of x is going to be 1 over 2 times the root of x, because x root of x is essentially x over to the power of 1 over 2, and the derived function would be 1 over 2 times x to the power of 1 over 2 minus 1, which is 1 over 2 times 1 over root of x, which is going to be 1 over 2 times the root of x. So now let a be 144 because it's a square number that's really close to both numbers. And now the linear approximation for the first one would be root of 145 is equal to root of 144, which is root of a, plus now the derived function um, using a times x minus a. So here it's going to be 145 minus 144, which is going to be 1. So essentially it's only these two, which gives us 12 plus 1 over 24. Now the linear approximation for the second one is the same thing except for the last part. And now because this is a smaller number than 144, 143 is a smaller number than 144, when we subtract 144 from 143, we get minus 1. So now this part becomes negative, and it gives us 12 minus 1 over 24 instead of 12 plus 1 over 24. So now the solution for both is going to be as similar to the previous methods. So this 12 plus 1 over 24 minus 12 minus 1 over 24, which gives us 1 over 12, which is around 0.83. So these are three methods that could work for trying to approximate the solution for this problem, and they're all similar in some way because they all use um, the same strategy. Thank you very much for watching, and see you next time.